Right, in this lesson, we're going to talk about reflections. So there are two types of reflections. We got a horizontal reflection, and the second type is a vertical reflection. So in this lesson, I'm going to describe to you what happens in a vertical reflection. So moving on to the next slide here, it says when the graph of y is equal to f of x is transformed to the graph of y is equal to negative f of x, we have what is called a vertical reflection. All right, so taking a look at this function, y is equal to negative f of x. You can rewrite it. If it's easier to visualize what's happening here, that negative can actually come in front. So this function can be rewritten as negative y is equal to f of x. All right, so if I'm going to compare this function to this function, what ends up happening is if you take any point on the original graph and you vertically reflect it, the y value becomes negative. So this value this coordinate or this point becomes x negative y, and that all stems from the fact that this is the transform function. Y becomes negative under a vertical reflection. So we are going to perform a vertical reflection here on this given graph down here. And so to perform any type of transformation, what you want to do is pick 4 or 3 points to help you sketch the transform graph. So I'm going to pick this point right here, which is a 0. That's at negative 2 comma 0. I'll pick this point right there, so that's about 0 comma 3. And let's pick another point, 4 comma 5. And just so we have a really nice pretty graph, let's pick another fourth point. So right there, 9 comma 6. So now we're going to apply our transformation, and our transformation, remember, is a vertical reflection. And what happens under a vertical reflection? Well, all my y coordinates become negative, and all the x coordinates stay the same. So my first point is going to become negative 2 comma a negative of a 0 is just simply 0. So notice this point didn't really change. 0 comma 3 becomes 0 comma negative 3. Next point becomes 4 negative 5. And finally, this last point becomes 9 comma negative 6. So all my y values became negative, and all the x coordinates stayed the same. So from here, we're going to go ahead and graph those points and connect them as best as we can. So let's start with negative 2 comma 0, which was a point that stayed the same. 0 comma negative 3, which is right there. 4 comma negative 5, which is right there. 9 comma negative 6, which is the last point, is right there. So remember, we still want to keep it the same shape. So it's going to look just like this. If you connect them, you should get a nice graph just like that. So there is our vertical reflection. All my points went vertically down or vertically reflected in the x-axis. Okay, so when you have a vertical reflection, it's in the line the x-axis. Okay, so your x-axis acts as a mirror when you vertically reflect a graph. Also notice, were there any points that stayed the same under this transformation? Well, it was that point right there, which is the x-intercept. So that is an invariant point. It's a point that stayed the same under the transformation. And actually, that's going to be the same case for all types of graphs. When you vertically reflect it, all the zeros, all the x-intercepts are all going to stay the same. And so that's my lesson on vertical reflections.